And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we're talking about how there is a series of solar protons on the way to Earth. We're expecting it to arrive late Wednesday and early Thursday. It is the ejecta from a coronal mass ejection. We're looking at the sun here in colorized magnetogram. Sunspot 2822 is beta gamma delta class. We've seen the umbrae get a little bit closer to each other here. The likelihood of significant solar flares still there. Likelihood of major coronal mass ejections not really so high. Also, we've got sunspot 2823 down here, having recently achieved beta class, as well as we've got two opposite polarity umbrae there as well. Here's a close-up in 304 angstroms of sunspot 2822. And here's a view in the same wavelength of 2823. And again, this one has increased in its complexity a little bit over the past 24 hours. Here's the northern hemisphere, complete with an Earth scale for you there. You can see the size of sunspot 2822, as well as a great view of the North Polar region. This is 193 angstroms ionized iron. And here's another view in the same wavelength of the southern hemisphere. Coronal holes rotating in. And again, we can expect some coronal hole wind from the one in the top center of your screen within about a day as well. So we're expecting the coronal mass ejection strike to occur at the same time as a coronal hole wind stream regime. And so we may actually see a thing like a reduction in the plasma temperature on the real solar wind as a signal. And let's get to some more data here on our daily space weather. Here's a chart, a diagram rather, of the solar system. There's where things will be in 1 week. Happy new moon. Did you have any reverse werewolves who got less hairy and slept well as a result of the new moon? Here's a star chart. And you can see Saturn and Jupiter there rising ahead of the sun. I've drawn in the ecliptic and faced mine to the south. I use in-the-sky.org. I would note also that Deneb will just be circling Polaris all summer long. One of the more important stars in the sky. More about that perhaps in a later video. And the 10.7 centimeter radio flux, which is the radio frequency output of the upper chromosphere and the lower corona. The number for that is currently 77, I think it is. Yeah, 77 solar flux units is the 10.7 centimeter radio flux right now. Here's the 1-year chart of that. It's this black line. That's from solon.info. And you can see this geomagnetic unrest forecast for late tomorrow night, Wednesday, May 12th, and early in the morning, Universal Time, Thursday, May 13th. So that's the forecast for the coronal mass ejection strike according to NOAA. No real argument there. There is a possibility that it is moving faster, and that is some wording included in the NOAA description. I would tend to think it's slower, as the radio burst speed was only in the 400 kilometers per second range. And let's get into seismicity. Looking at earthquakes is next on our list. And you can see a significant earthquake lull here. No 7+ magnitude quakes since the 20th of March. And you can find this screen yourself at volcanodiscovery.com, a fantastic website. And with another one of their screens here, you can filter by magnitude. We did see some 5+ magnitude quakes coming in just a little while ago here, an hour and 12 minutes before we recorded the video, as well as a 3-hour-old quake here in Mexico, and a 2-hour and 41-minute-old quake in Honduras in the 5 magnitude range. Let's check out the USGS site here. So nothing over a 6 magnitude, nothing over a mid-5 magnitude range. And we'll just scroll up the list here. Kermadec Island saw 5.3. Guam saw a deep quake at a 4.4 magnitude at 180 kilometers depth. Western South America saw a deep quake at a 4.5 magnitude. Russia saw a deep quake on the Kamchatka Peninsula. That was a 4.6 magnitude. Here's another deep quake south of Kamchatka there. Extreme eastern Siberia, a 4.2 magnitude at 344 kilometers, and a 4.7 in the Banda Sea there, north of Australia. So a series of deep quakes happening. A 5.1 struck the Philippines, a 4.0 deep quake struck western South America as well. The Honduran 5.1 magnitude quake was over 100 kilometers depth, so a bit of a deep earthquake event going on there, folks. Let's check volcanoes. Volcanoes over the past 24 include Suminosejima, which exploded, produced a volcanic ash cloud of unknown size. Please do not attempt to hang glide over the caldera. Cinnabung. Don't square dance the caldera at Cinnabung as it's exploding and producing a 10,000-foot altitude plume of volcanic ash above its caldera. Semeru on the Indonesian isle of East Java, exploding as well, 14,000-foot ash plume there. Pacaya in Guatemala, producing sporadic emissions as it, quote, mildly, end quote, explodes. Sabancaya in Peru, exploding. Intermittent emissions have produced a 23,000-foot plume of volcanic ash there. And Nevado State Chilean is reminding us not to pole vault the caldera as it also explodes. 14,000-foot plume produced by intermittent emissions there in the central Chilean volcano. Do not pole vault the caldera. This public service message brought to you by at massive personal risk and expense from smAsho.com. Next, looking at the GOES-16 sun-facing suite of instruments, the X-ray flux showing some B-class flares, practically moving into a B-class background X-ray signature here. No major flares over the past 24 hours. We did see a C-class flare. Actually, 2 C-class flares on Sunday, May 9th. A tiny little spike in the proton flux here, just barely making it over the 1 particle per cubic centimeter. Not what you'd call a real proton strike there, folks. Here's the GOES magnetometer over the past 3 days. Another one of the sun-facing suite of instruments on the GOES-16. Fairly normal range here. Here's the polarity of the heliospheric current sheet. We're looking at the top view ecliptic plane field plot. Earth currently in a South Pole-oriented current sheet, shown here in red, and we're not expecting a change to that coming in anytime soon. Here's the line of sight viewpoint for the same data. And we'll also show you the sun's B field on the coronal hole line of sight plot. And there you can see a series of South Pole-oriented coronal holes shown in red. Some North Pole coronal holes also reaching down and then dissipating, becoming filled with plasma. And here is the detected sunspot groups and coronal holes animation on the Integrated Space Weather Analysis Center, and you can see both sunspot 2822 and 2823 are beta-class sunspots, which increases the likelihood of significant solar flares. Let's check out geomagnetism. Global geomagnetism currently at a KP of 1. The planetary K index measures global geomagnetism. And thanks to our new viewers who were not aware of that, speaking of global geomagnetism, we're going to get to it in a minute. First, the real-time solar wind. Looking pretty weak here at a solar wind speed of only 325 kilometers per second. Solar wind density only 4.72 protons per cubic centimeter. And by the way, that tiny proton strike happened right here at 1710 was that tiny proton strike. And you can see it was accompanied by a small increase in the solar wind density, the plasma temperature, which is the green line at the bottom, and a dip in the solar wind speed to 349 kilometers per second at that moment. Also, the BTBZ shifted at that same period in time. Perhaps some high-speed ejecta out in front of the main coronal mass ejection there. A very minor signal, barely even noticeable. Next, looking at magnetohydrodynamic pressure here in the Earth geospace. We'll let that play through as it's refreshed. And it's just easier and more timely for us to allow it to play through than to attempt to edit the video. In any case, this is 4 hours of data, and you can see fairly homogeneous magnetohydrodynamic pressure here shown in nanopascals. It's all based on the space weather modeling framework, and if you want to read about that, click on the details tab at the bottom of the page. You'll find all kinds of links to where the data's from. Next, looking at geospace delta B changes in the Earth's own B field. Since there's a polar excursion going on, we're interested to see and perhaps even forecast what will happen next with the geomagnetic excursion, in which the Earth has two north poles, geomagnetic ones that is, and the south pole is someplace south of Australia, thousands of miles from the south geographic pole. Homogeneous magnetic perturbations here over the past 24. And let's take a moment to welcome our Twitch viewers. So today we'll do a short cosmology segment. We'll talk briefly about Sagittarius A star. So, the core of the Milky Way galaxy is a supermassive radio source known as Sagittarius A star. And if you look at this lovely diagram here, this is an animation of the supermassive blue giant stars that are orbiting Sagittarius A star. Now, we don't have a very good view of Sagittarius A star from our solar system. There are apparent spiral arms of the Milky Way galaxy which are in the way of a good view of Sagittarius A star. So it only shows up in certain frequencies. However, we have noted a series of massive stars orbiting it at, let's just say, solar wind speeds. These stars are traveling at hundreds of kilometers per second, the speed that we would expect to see a comet traveling. And these massive stars are, of course, orbiting the supermassive radio source at the core of the Milky Way galaxy known as Sagittarius A star. So let's take a quick look at that, but first, I would invite all of our viewers to check us out at twitch.tv/smAsho, where we're currently streaming live. There's a great mobile app for that as well. Twitch.tv/smAsho. Thanks to our new subscribers over at YouTube. Don't forget to check our playlists there as well, youtube.com/smashamash/playlists. We're also on BitChute. Thanks to our BitChute subscribers. Yesterday we put an exclusive out there. Our meteorology segment was a BitChute exclusive yesterday. And I'd like to welcome all of our viewers to the Neo Renaissance. Check out our social media links and so on. Leave us a comment. Let us know what your favorite social media is. Today's featured product is available at the smAsho merch link right at the homepage, smashamash.com. Smashamash.org will redirect you. Click on the smAsho merch link and you can find this. Today's featured product is the Do Not Pole Vault the Caldera tote bag. So we got my mom and Smash Staff's mom one of these for Mother's Day. One of them has arrived. The print quality is exceptionally high, so perhaps pick up a tote bag. If you'd like to go to the grocery store and tell people not to pole vault the caldera, you may find lots of stupid people at the grocery store, and that's why we make public service messages, because there are a lot of dumb people. So today's cosmology segment is going to start out with information about Sagittarius A star. So Sagittarius A star, again, is not particularly bright in terms of X-ray. Here are the X-ray transients over the past 16 years. It's this top image here. Here's a 30-day chart of the X-ray output from the massive radio source at the core of the Milky Way galaxy. Milky Way galaxy team for the win. It's Sagittarius A star. Now, if you want to search for this, you want to type in SGR space A asterisk, and that is the X-ray source at the core of the Milky Way galaxy. So there it is in, I'm not sure what spectrum that is. Let's go to Aladdin Light here, and we'll look at it in a couple wavelengths. So in infrared, it's going to look very bright as it is right in the core of the galaxy. So there is a lot of hot plasma in that area. No surprise there. Let's check it out on Chandra. And there you can see the extremely busy X-ray environment at the core of the Milky Way galaxy. And that's the location of Sagittarius A star. That's the relatively dark region that we see these massive stars orbiting, some of them with a periodicity as low as 12 years. And there it is on the multi-mirror, XMM Newton. Let's see if it shows up in UV. It's probably not going to show up in UV at all. It's going to be very bright. How about Finkbeiner? Yes, hydrogen alpha. There's a lot of hydrogen around the core of the Milky Way galaxy, and there you can see the way the hydrogen is distributed. It's quite focused on the galactic plane, which you can see right here. Sagittarius A star, today's featured object. And let's go to the astronomy picture of the day. It's Uluru, as well as the largest object visible, the largest single object visible to the naked eye. It's Betelgeuse. How do you find Betelgeuse? Well, you see these three stars that are in a straight line. The middle star forms a perpendicular pointed directly at Betelgeuse. So if you want to find that, find Orion. It's a very conspicuous constellation. That's how to find Betelgeuse. The three stars that make up Orion's belt point directly at it. And here's a great image of Orion and Uluru, otherwise known as Ayers Rock in Australia. And that's today's Cosmology segment. We kept it pretty short here at the Smash News Network. And geez, did I fail to show the graphics, folks? Anyway, there's the graphics of that. Here is the hydrogen alpha around the galactic core. If you zoom way in, that's where Sagittarius A star is located. Check out those large, dense clouds of hydrogen. Here it is on the Chandra, the X-ray telescope. And you can see how busy the X-ray region around the core of the Milky Way galaxy indeed is. Sagittarius A star, and there's Ayers Rock. There's the star that points at Betelgeuse. Orion's belt forms a perpendicular line pointing right to Betelgeuse. So we'll have to say goodbye to Twitch, and we'll bring you back. And thanks for leaving a comment, John. We'll bring you back for the meteorology segment. Let's continue on. Now we're going to talk about electrons. There are belts of them surrounding planet Earth. Here's a diagram of the Van Allen belts. Here's a one-year chart of the greater than 2 mega electron volt electron flux as reported by Solon.info. There's a 3-day chart. And we're in a fairly moderate range here, and we see chaotic electron belts once again. We don't see any charging hazards as the electron density really isn't that high. High electron densities can charge up satellites and cause them to shut down, and communications errors and so on. Here's the relativistic electron forecast model, and we're expecting a dip here with the arrival of things like coronal mass ejections and coronal hole wind streams. Here's a total electron content forecast. It's showing you the entire air column and the electron density therein. It shows you where GPS errors are most likely to occur, and indeed we're seeing chaotic electron belts here showing up at nighttime once again. Surprisingly high densities here, even on the non-Earth facing side. Even on the non-sun facing side of the Earth. Next, looking at just one slice of that, it's the F ionosphere layer located here at about 300 kilometers of altitude. The F ionosphere layer is in many ways the bridge between space and Earth. And you're looking at vibrational frequency, millions of vibrations per second, otherwise known as megahertz. And the ionosphere is looking fairly normal here. And we'll just let a bunch of the data play through here before we bring up the latest image. And here's the latest image coming in at 8:15 Universal Time. Looking normal there at that time. Again, the F flare is located at about 300 kilometers of altitude. Feel free to pause the video, as this diagram also shows you electromagnetic radiation penetration into the atmosphere, as well as temperature versus altitude at solar minimum and solar maximum. And let's welcome Twitch back. Welcome back, Twitch, for today's meteorology segment. Some interesting stories to cover today. Let's get to it. First, surface winds on planet Earth. And I would note a very powerful anticyclone right here in the southern Indian Ocean. Some chaotic weather around the South Geographic Pole region kicking off. It's completely encased in low pressure. We'll get to it. First, the jet streams. There are the jet streams of the eastern world. Here are the jet streams of the western world. And we see quite chaotic jet stream flow here in the northern hemisphere once again. Although a concentrated jet stream over the North Atlantic. And here are the surface winds of the western world. Powerful low pressure system there northeast of Newfoundland. Continuing on, I'm always interested in where lightning's striking, especially if it's near me, so I use lightningmaps.org when I hear thunder. Powered by blitzortung.org. And we've got some terrestrial lightning here near Shreveport. And by the way, if you're about 80 kilometers away from a heavy thunderstorm, get out and look toward the thunderstorm. Take some time-lapse imagery of it. You may get images of something you were not expecting. More on that later. So a pretty concentrated thunderstorm here west of Shreveport, north of Longview. Quite a concentrated thunderstorm kicking up there. Also one south of Memphis. See, in this case right here, if you're in Memphis, if you look south above the top of these cloud tops, you may see some things that are quite interesting, such as sprites, elves, jellyfish, etc. Jellyfish such as this, spotted above a storm in China. Let's play the video. Courtesy AccuWeather.com. And this is what you may find yourself photographing if you take time-lapse photography above major thunderstorms. Also, you can do long exposure photography for this, and keep in mind the UV outputs of these are often not even visible to the naked eye, similar with auroras. So if you're in a spot where you're likely to see auroras, or if you have this sort of a view of a thunderstorm, set your camera up and take some imagery of it. You may get something that'll blow your mind. Here's the NASA GOES lightning mapper. Heaviest lightning of the past 6 hours here is in southern Texas, actually. Very concentrated lightning bands visible there. Next, I'd like to thank our patrons, a true source of funding for the content. Thanks, patrons. These videos might not even exist anymore had it not been for you. Patreon.com/smashamash if you'd like to see the videos continue to exist and be publicly visible and free for most to view. Patreon.com/smashamash. You also get earlier alerts than anybody else. You get all kinds of other media and information nobody else sees. And let's take a look at pressure cells here. Here's the current pressure situation. I would note a powerful anticyclone here over Wisconsin. High pressure centered there over the Wisconsin-Minnesota border. Here's the Euro forecast for pressure at 12 noon tomorrow. And we're expecting that high pressure system to remain in place. At least according to the Euro forecast. Did you see the rocket last night? There was a rocket that was visible through a large portion of the mid-Atlantic states. Here's some imagery of that. Instagram /@JerseyPortraits if you want to follow this user on Instagram. Great imagery there of the rocket visible from the Jersey coast. Continuing on, here's the U.S. Doppler radar map. Snow continues to fall in Colorado. It looks like some wet snow to say the least. It must be that hot air on the trailing edge. Is the hot air coming from underground, or is it coming from a terrestrial source? Where is all that hot air in Colorado coming from, folks? Oh my God. Here's the cloud layer, and here's the water vapor. Let me speed this up. So there's the water vapor map. Here's the cloud layer, the 3.9 nanometer radiation interactive weather satellite here, the NASA GOES interactive weather satellite suite. And so we've got this flow of warmer air coming down here, coming like this. This dry massive air is kind of just hanging out. That's a high pressure system right there. And the jet stream's actually way up here right now. So some milder temperatures. And again, there's the Doppler radar. There's the cloud layer. And there's your water vapor map. And that's today's cosmology segment. I mean, meteorology segment. See you later, Twitch. We'll see you next time. Here come bonus features for our daily space weather. They'll consist of some hydrogen alpha imagery from Udaipur, India. So here's some of the latest imagery here from the National Sunspot Observatory, the Udaipur, India ground-based solar observatory. There are still some filaments. You can see some down here. You can see some over here. Again, likelihood of additional solar flares has gone up a little bit. Here's the latest colorized magnetogram. Do we have another sunspot forming in the northwest? We'll have to keep an eye on that. And when I say ion, well, the pun is intentional. It's not a sunspot yet, but it is getting light there, so we may be seeing a sunspot forming. Here's 2822, and here's 2823. Barely beta class, as this is a very weak umbra. The greatest possibility for significant solar flares comes from 2822. Here's a full disk view in 171 angstroms, my favorite wavelength. And we'll close things out with an equatorial view, which includes both sunspot groups. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Don't forget to press like, share, subscribe, etc. And may that solar wind be at your back.